Alrighty, number 4, so same process. Factor and cancel if possible. Alright, x times x or x squared plus minus, so that when you multiply you get negative 12. Leading coefficient is 1, so just find out what adds up to a negative 1. At the same time multiplies to negative 12. What's that going to be? Minus 4 plus 3. Nothing cancels, so since nothing cancels, right off the bat, we have no holes in the graph. Intercepts. Alright, x-intercept. That is when your numerator is equal to 0, your numerator is negative 1. It is never equal to 0. So there are no x-intercepts. Y-intercept. Plug in 0. Alright, so we plug in 0, we will get 1/12. Alright, 0, 0, negative 1 over negative 12 is 1/12. Alright, so that's 1. 112.08, somewhere around there. So there's our y-intercept. Should be closer to the x-axis. Asymptotes. Okay. Let's see what we got going on there. Let's switch the color. Alright, horizontal asymptotes. That's going to be at the line y equal to 0, the x-axis. We know that right away because the denominator has a degree of 2. The numerator has a degree of 0. When the denominator has a higher degree, horizontal asymptote is at the line y equal to 0. Alright, goes back to the 3 cases that I discussed on the previous video, in the previous lesson. Vertical asymptotes occur when your denominator is equal to 0. So that one will give us x equal to negative 3. This one will give us x equal to 4. Make sure you write the equation, not just negative 3 and 4, because it represents a line. There's 4, there's negative 3. Draw it by hand, make sure it's dashes and straight. Mine isn't as straight as I would like. There it is. What else? Will this cross the horizontal asymptote? Well, set it equal to that value, which we already did in this case because that's what we set it equal for the x-intercepts, and we got this here. So it'll never happen. It'll never be equal to 0. So you'll never get a y-coordinate of 0. So that is what that looks like. No x-intercepts, it'll never cross that. Our denominator, once we factored it out, x plus 2, let's put that back on there. These had a multiplicity of 1. So it'll approach these vertical asymptotes in opposite directions as an odd multiplicity. Alright, make a table of your choosing to get more and more accurate graphs, get more points on it, find out exactly where they are as needed. But again, multiplicity of 1, so these will go in opposite directions. It's never going to cross the horizontal asymptote. There's no y-intercept, so at some point it has to turn around. The minimum is actually going to occur when x is 1/2. So somewhere in here you have your minimum. It's calculus to find the minimum. Okay, or with the calculator, and we're not there at this point. So that's number 4, asymptotes, holes, none, and intercepts. And again, you want more detail, pick some x's you're choosing, pick them all over the place, either side of the asymptotes, intercepts, calculate the y-coordinates, and plot away. So there's number 4. All right, number 5 is set up for you. Nothing factors, nothing cancels, so we'll just jump right in. Intercepts, so nothing cancels on the bottom, so we have no holes in the graph. X-intercept occurs when it's equal to 0, or when your numerator is 0, 2 is never 0. So no x-intercepts. Y-intercept is when you plug in 0. Plug in 0, we're going to get 2 over negative 3. That's gone, multiply, yep. All right, y-intercept, negative 2/3. So negative 1, negative 2, so negative 2/3, somewhere in there, a little further than halfway. All right, asymptotes. We'll be done with this guy. Let's go to horizontal first. The degree of your denominator. So if we were to multiply this out, FOIL, box method, distribute, whatever you want to do. 3a minus 1, you would get this. So degree of my denominator is 2. And you didn't have to multiply the whole thing to determine that. I just did, but you didn't have to. Just x times x. Degree of your numerator is 0. So if the degree of your denominator is larger, horizontal asymptote at the line y equal to 0, which overlaps the x-axis. Will it ever cross it? Well, set it equal to 0, which is what we did for the x-intercept. And it's never the case, so it'll never cross it. So it's never going to cross that. Keep that in mind. So all that's left is my vertical asymptotes. That occurs when the bottom is equal to 0. So plug in negative 3, you get 0. When the bottom plug in 1, you'd also get 0. Those are our vertical asymptotes. We got 2 of them. 1, 2, 3. 1. All right, it's never going to cross the horizontal asymptote. So this one is going to have to turn around at some point. Something like that. The maximum, the relative maximum is in here somewhere. If it's symmetric, it's in the middle. May or may not be, depends on the function. At this point, it will be calculus to determine that, or calculator. My vertical asymptotes had a multiplicity of 1. So the graph will approach it in opposite directions. So it approaches to going down here, it'll go up here. And then the end behavior, as x gets really, really, really large, so I don't know, plug in a billion, trillion, you'll get numbers that are smaller and smaller, closer to 0. All right, same thing on the other end. It'll go in opposite directions because multiplicity of x plus 3, which gave us that asymptote is odd, so opposite directions. Again, if you're not sure, just pick some x values around it. So we know negative 3 is undefined. So we plug in negative 4. Plug in negative 2. Let's see where the points will lie to get you a better idea if you're unsure the directions that they go. And behavior on the left. So plug in very small numbers, negative, a billion, trillion, whatever you want. You're going to get a very small y coordinate, getting closer and closer to 0, your horizontal asymptote. So number 5 is done. Nothing cancels, just graph this guy. O's, asymptotes, intercepts. All right, number 6. Back to this guy out. Let's see if anything cancels, giving us holes in the graph. All right, positive times a negative will give us a negative. What times what is negative 2? That adds up to negative 1. So negative 2 plus 1. On the bottom, x times x for x squared. What times what gives me a positive 1. So either both positive or both negative. They're going to both be negative. So that they add up to negative 2x in the middle. On the bottom, these two factors do not cancel. So there are no holes in the graph. That only occurs if one of those factors cancels. You then take that x-intercept, that x value, plug it into the simplified version to see where this hole is to find the y coordinate. Okay, so let's get to this. Intercepts. So my x-intercepts occur when the whole thing is 0. The shortcut is to set your numerator to 0. So we have two x-intercepts, -1 and 2. So -1 is going to cross the x-axis, +2 is also going to cross the x-axis. So that's there. Y-intercept, plug in 0. So 0, 0, 0, 0, -2/1. So -2. So y-intercept is -2. So there's that. Asymptotes. Okay. Check this out. Asymptotes. That's kind of messy. Horizontal. Let's go ahead and do that one first. If the degree of your numerator, 2 in this case, is equal to the degree of your denominator, the horizontal asymptote will occur at the line of the ratio of your leading coefficients, 1 over, 1. So we have a horizontal asymptote at the line y equal to 1. Well, would it cross it? We have to test that out in a second. Vertical asymptotes occurs when your denominator is equal to 0. That occurs at the line x equal to 1. Plug in 1, 1 minus 1 is 0. Okay. So we got x equal to 1. There is that value. All right. So is it going to cross the horizontal asymptote? So I'm going to erase that. There's no holes. So set it equal to that value. So I'm going to take this guy and I'm going to set it equal to it, and we have to solve for x to see if that occurs. And actually, it's going to be easier to work with the original one. So I'm going to clear this out here. So set it equal to 1, so multiply both sides by your denominator, so we're left with x squared minus x minus 2. So multiply that on both sides, x squared minus 2x plus 1. Solve this, cancels. Let's add that one, x is 1 plus 2x plus 2x, and then plus 2 plus 2, I'm sorry, that's 3. So it's going to cross the, it's going to have a y value of 1. So what I did, I set it equal to 1. I found that happens when x is 3. So it's going to cross right there. So keep that in mind. All right. Other than that, some key points, key features. Our denominator, if you recall, when we factored it out, it was x minus 1 squared. So this vertical asymptote that it gave us, it's going to approach it in the same direction. So it's going to approach it here. On the other side, it's also going to approach it. So it's going to go towards it in the same direction because your denominator has a multiplicity of 2 once you factored it out. All right. So we want a few more details to this. Fill out a table, pick some more x's. It's not going to cross the horizontal asymptote again, so it's just going to approach it, getting closer and closer over here. If you're not sure, pick some x values, but when we set it equal to it, we found out it only crosses once when x is 3. Over here, it'll do something. At some point, it'll peak off, and then it'll come back, getting closer and closer to it. I plugged in a few values to test it out. Again, to find out this relative maximum wherever it is, it'll take calculus or a calculator. But we're done. There are no holes in the graph because nothing canceled. We have our intercepts and asymptotes. And that's it for this lesson. Any questions, reach out to me. And there we go.